So first and foremost, it's a real honor to be here. Like they said, I'm actually from Atlanta, born and raised in Atlanta, but been living overseas for quite some time. And sometime in the interim, I started giving presentations at conferences, international conferences. I've done a few in the States, but never actually in Atlanta. So this is the first time. And I actually have my sister joining me, so that's also something different to have a family member. Not into tech, but yeah, we'll see what she thinks of it afterwards. All right. Yeah, so here we are. Java Users Group, Spring Users Group in Atlanta, and we're talking about Spring Framework 4.0 and up to 4.1, so what's coming up. My name is Sam Brannen, as I mentioned. I'm a Spring and Java consultant at a company called SwiftMind that I founded a few years ago in Zurich, Switzerland. And I am a graduate of Georgia Tech College of Computing. Anyone else go to Georgia Tech? One person, two people, okay. Not too many for Atlanta IT, I guess, but maybe they all move away. I've been developing Java for over 15 years, which is quite a long time. I don't know, does anyone have me beat in the audience? No, got me beat, all right, cool. I've been developing Spring as a core committer since 2007. I used to actually work for Interface 21 and Spring Source, and then moved on into my own consulting. But I continue to be a Spring trainer for Spring Source, VMware, Pivotal, whatever you want to call the company, and I speak at conferences on Spring, Java, and OSGI. Yeah, in terms of OSGI, I used to work on the DM server team, if you've ever heard of that, which is now Eclipse Virgo. And speaking of Spring user groups, I'm the co-lead of the one in Zurich, in Switzerland. So just a few words about my company, SwiftMind, experts in enterprise Java in general, focusing mainly on Spring, anything in the Spring portfolio, not just core Spring, also Spring Data, Spring Webflow, other things like that, batch integration. Also Java EE, OSGI, then best practices in software architecture and in engineering. You find us, in Zurich, but also online, as well as on Twitter. And I'll have some more links towards the end of the talk. If you have any questions throughout, just raise your hand, and we'll also have some time at the end to answer directed questions. Now, before we get in, I assume everyone is a Java developer, yes? And who actually actively uses Spring? Okay. Anyone on Spring 2.5? No. Spring 3.0? Yeah. 3.1? 3.2? 4.0? 2 people? All right. Okay. So we have a pretty big mixture there. Now, the agenda, we'll just start off with a kind of an overview of some of the major features we had in the 3X timeline, so 3.0, 3.1, and 3.2. Then we'll step into the major themes in 4.0. So 4.0, in case you don't know, was released last December, and we're already up to 4.03 with 4.04 coming out soon. Then we'll talk a little bit about Java EE and SE support in Spring and the core Spring framework. Then moving on to some of the new support for Java 8 features in Spring 4. Then at the end of the talk, we'll talk about some of the features that have already been implemented for Spring 4.1, and then moving on to some of the things that are up and coming. So, quick review, the major themes in 3.x. First up, lots of support for a new component model based on annotations mainly, so moving away from XML even more so than in 2.5. Things like annotated controllers, Spring at MVC, Java config, composable, custom stereotypes, and things like that. Also the Spring expression language, so have you used that actually in your code? Spell, a few people? Okay, so dynamic expression evaluation. Also comprehensive REST support for REST web services, adding the 3X timeline, and support for asynchronous web processing in MVC with Servlet 3.0, and then moving on into 3.1. Beyond that, lots of support for things like declarative validation and formatting. We'll see a mention of that in a few minutes with some of the specifications. Then, of course, scheduling was introduced in Spring. There'd always been support for courts, but there's out-of-the-box support for scheduling directly within core Spring and caching. We'll talk about that a bit more later on as well with JCache and some of the new support in Spring 4.0. In terms of the key enterprise specifications supported in the 3X timeline, first up we had JSR 330. So that's the dependency injection for Java. Common annotations like @inject instead of autowired for Spring. Things also like provider. We'll see that in another slide example later on as well. Also JSR 303, so declarative validation with bean validation 1.0 with declarative constraints using annotations like @not null and things like that. Next up, support for JPA 2.0 with persistence provider integration directly in Spring and also with transaction management powered by Spring, and Servlet 3.0. So I mentioned earlier asynchronous request processing, but also the ability to move away from web XML and XML-based configuration and have your Spring configuration, Spring application configured in totally with Java and annotations. Didn't really focus on that. So what I actually do in Spring, I'm the lead of the testing module. So if you've used any of the things like @context configuration, any of the annotation-driven configuration in Spring, that's what I do. You see my name scattered across the code there. So I'll point out a few of the main features we added in testing in the 3.x timeline. One thing we added was support for embedded databases. It's not particular to testing, but often used in tests to launch an in-memory database quickly and then have it shut down after your tests. So this can be done either programmatically in Java config or with the JDBC namespace in XML. We also added support for testing with @configuration classes, so Java config, as well as declaring active profiles that should be used when you're integration testing. Next up in 3.2, one of the main features that people have been waiting on for many years actually in Spring was the ability to be able to test a web application in Spring, and we added that in 3.2. And in line with that, we also added support for testing with context hierarchies in your integration tests. Next up, the Spring MVC test framework. Who's actually heard of that? 3 people? 5 people? Okay. So if you're writing, or if you're using Spring and Spring MVC, I highly recommend that you check out the Spring MVC test framework that was introduced in 3.2, and it really simplifies how you unit test your annotation-driven controllers in Spring MVC. Now here, just as an example, make sure we're on the same page in terms of configuration, basically what we consider state-of-the-art or the status quo if you're writing a new Spring application using Java-based annotation configuration. Here we have basically my book admin service, implementing our book admin service interface, quite standard Java, and then here at the top we're annotating that with that service to say this is a component, a Spring managed component, and specifically it is a service type component. And then within our, for our constructor, the way we provide our dependencies, so dependency injection with Spring, we're doing this with a standard annotation, @inject. You could, of course, use @autowired from Spring, and then having your dependencies injected by type. Then for things like declarative transaction management, declarative caching, those kind of things, you can use different sets of annotations. Here we have @transactional from Spring, saying basically that when this method is invoked, it should be run in a transaction. And actually, without seeing the import there, this could actually come from JavaX annotation transaction, which is a new annotation we'll talk a bit about later on. So that's the annotation-driven component model. And when we talk about configuration classes, we're talking about Java config as opposed to XML-based configuration. And here we see a standard class here, not implementing anything or extending anything, just annotated with that configuration. So that says this is a Spring component. Specifically, it is a configuration class, so it defines beans, and you declare your bean definitions with @bean annotated on methods, using the name of the method as the bean ID or bean name, and the return type as the type. Then you can just use any standard Java, anything you need to do, so you're not restricted like you would with XML. You can do anything here you want to programmatically, and you can also reference other beans either within this configuration class or in another one, and we see that here with @bean here. So this book admin data source is being passed here to the set data source method, and it's picking it up from this other @bean annotated method in the same configuration class. Now again, this is what we consider basically status quo, or the best way to configure your applications with modern Spring applications. Composable stereotypes. So we saw earlier we had @service. That's what we call a stereotype. It's the generic term is a component. And then we have things like services, repositories, controllers. Those are different stereotypes. And when we talk about composable, we're talking about combining several different annotations to come up with our own custom annotations. Now, who knows? Everyone knows what an annotation is, right? I hope. Who knows what a meta annotation is? No one. You don't know? Meta annotation. Anyone? Are you? Okay. Just want to make sure at least you two know what it is. Okay, so meta annotation is anytime you have an annotation on another annotation. So it's kind of used in a meta sense. It's very important to know that. If you ever look at the definition of or declaration of an annotation, they're all annotated with other annotations. You might see something like at retention or at target, stuff like that. So it's when you annotate physically in the source code, when you're defining an annotation, you put another annotation on top of it. That's a meta annotation. And that's a way to combine multiple annotations. The reason this is necessary is that the Java language gurus decided that they didn't want to have inheritance with annotations. So an annotation cannot inherit from another annotation. But you can annotate an annotation with another annotation. So in that sense, you kind of have this meta annotation hierarchy, so to speak. And we make use of that in Spring. Some other frameworks do as well. Basically, let's go say in here, you combine several meta annotations onto one custom stereotype. And these things are picked up automatically in Spring. You don't have to do anything special. You don't have to tell Spring to look at these things. It just happens for you on the fly. And this is what this looks like. So here we have a declaration that we're writing in our own code base, public at interface my service. So we're defining an annotation at my service. We see that it's annotated with a few things from the JDK here. So we have at retention, telling Java where this annotation can be used. And then we see a few different annotations from Spring. So we see service, scope, and transactional. Basically, what we're defining here is a request scoped transactional service. And we're combining all three of these annotations into one custom annotation that we can then use across our code base, thereby reducing boilerplate code. So then in our book admin service, for example, we could just annotate that with at my service. And these things are all taken into consideration by Spring out of the box. And we'll see in 4.0 how that actually gets even more advanced. So next up, some of the themes in Spring 4.0, the main themes. First and foremost, one of the goals is to make sure that Spring is ready for new application architecture, so what we consider modern in 2014. For example, instead of having a full-blown Java EE application server, you might want to have an embedded web server, maybe embedded Tomcat or Jetty. You might see that used, for example, in Spring Boot. And also non-traditional data stores, so not just SQL, maybe some NoSQL, some graph databases, et cetera. Beyond that, you might be looking at some lightweight messaging options, or even WebSocket-style architectures, and even so custom asynchronous processing with some convenient APIs. So if you're looking at some more reactive type implementations these days and some big data crunching. To make some of that possible, we have some new baselines. So we're now basing Spring on Java SE 6.0 Standard Edition 6 or higher, and Java EE 6 or higher as well. And here we have a focus on, well, we support, Servlet 3.0, but we're focusing on 3.1, and also the recommendation is to go with Servlet 3.1 whenever possible. However, at runtime, we do still support Servlet 2.5, so you can be using Spring 4.0 and deploying to a Servlet container using Servlet 2.5. However, for example, some things like the testing support does not work with 2.5 anymore. The testing support requires 3.0, and some other things require 3.0 as well. Of course, the asynchronous processing requires 3.0 and 3.1. In terms of cleaning up, 4.0 is a major release, right, moving from 3.2 to 4.0. So we took the opportunity there to actually get rid of a lot of the things that have been lying around for many years. So all deprecated packages have been deleted. In addition, we've removed a lot of deprecated methods and fields. So basically, if you want to upgrade to 4.0, you want to be on 3.2 and actually paying attention to the warnings. So when you see deprecation warnings in the code that you currently have, you want to go ahead and find out what's the right way to upgrade, what's the next step to take, so that when you move to 4.0, you won't run into situations where your code just doesn't compile. Because again, we actually deleted some things, so if you're relying on something deprecated, once you upgrade, it just won't compile. Of course, that'll be pretty obvious if it doesn't compile. Third-party libraries, we've also had some upgrades there. One of our main goals here was to make sure that the libraries that Spring depends on are modern, so to speak. So meaning that the minimum versions we rely on are releases of third-party libraries that came out mid-2010. For example, Hibernate 3.6 and above, Quartz 1.8 or higher, and then EHCache 2.1 or higher. And in 4.1, we're also bumping some of these up once again. And that's it for some of the background information. Now we'll talk about some of the Java 8 language features and API features that Spring 4 either builds on or makes use of. First up, land of expressions, then method references, Who's actually, everyone's heard of lambda expressions, right? I hope so. Who's heard of method references? A few people, okay. We'll see an example of that later, actually both of these. JSR 310 date and time. Who uses JOTA time? Anyone? A few people? So this is basically the standardization of JOTA time, and Spring supports that. Repeatable annotations, has anyone heard of those? No one? Okay, we'll briefly talk about that. And parameter name discovery, basically left out of every blog about the new features in Java 8, but it's something important to Spring, so we'll take a look at that and see why it's important with Spring 4.0. First off, before we get to that, a bit about Groovy. So using Groovy, is anyone using Groovy in their projects? Yep. All right, so you probably have a mixture of Groovy and Java, right? So in Spring 4.0, the landscape changes a bit there. Basically with 4.0, we have a now smooth out-of-the-box experience for a Groovy-based Spring application, so you can actually write your configuration in Groovy. You can even write your entire application in Groovy now. You're not limited to sometimes having to use use Java instead of Groovy. And to make that happen, some things in the background, we have some adaptations in our aspect-oriented support, so ARP support with special handling of Groovy objects. And also Groovy-based bean definitions. We'll take a look at that, but that comes from Grails, from the bean builder. Some people might be familiar with this. That's now actually a core element in Spring. One thing I will point out, however, in 4.0 we have all the support for Groovy-based bean definitions and configuration, but we don't have a dedicated web application context for Groovy. That's coming in 4.1. Talk about that later. And we don't have testing support, so a way to use the integration support in the testing framework to load your configuration from Groovy config scripts. And that's going to be coming in 4.1 as well. Just two things we somehow, as a team, overlooked. Not really sure how that would happen, but happens to the best of us. So here's an example. Writing Spring bean definitions instead of with XML or instead of with Java config, as we saw with that configuration. Basically, you can use this Groovy DSL, so this domain-specific language. Looks a lot like XML. It's basically a Groovy representation of the XML that you've probably come to know over the years. So here we see you have beans, thinking about this as the top-level element in your XML configuration file. And we can also import namespaces, so schemas, just like you would in XML. And here we're saying we want to use the XML namespace util from using this URL. And then we see we can actually reference that just like in XML, so util.list, and then providing an ID, and basically using this list element from the util namespace. And in terms of individual beans, each bean is just a method with the name of the method being the ID or name of the bean, and the type there in parentheses. So this is creating a person object, and then a very simplified way here of setting the properties. So this is like the name property, age property, props here. So this would be a Java util properties object. You can just define inline here quite conveniently with Groovy. And you also have support here for things like arrays and lists and maps, just like you would normally in Groovy. So much more concise than what you'd have in XML. And if you're going with Groovy for your application, it's nice that you can now configure your application with Groovy as well. Has anyone seen this before? A few people? Okay. Conditional beans. So who's heard of profiles? Bean definition profiles. Who's actually used them in application? Okay, so bean definition profile is a way to say, I have a collection of beans, kind of like a logical grouping, and I want these beans to be used when I deploy to the staging server, and I want these beans to be used when I deploy to production. Oftentimes you use that for things like deciding which data source to use. Do you want to talk to the test database or talk to the live production database? And in the past, that was only possible with profiles, so the @profile annotation. And for 4.0, we came up with a new approach to that, to having conditional beans. This is a new generalized model for conditional bean definitions, and it's more flexible and more dynamic than what we had before with profiles. So basically, you can use this for smart defaulting and a programmatic approach. So with the bean definition profiles, you had these static names of profiles. So you had a profile called maybe production, but that was the name. It was hard-coded to that. There's no way to programmatically say, well, I want to check maybe the IP address of what I'm running on, or maybe check some other information and see what environment I'm running in. For a lot of examples of this, you can check out Spring Boot. I think you guys had a talk on that in the past, recently, yeah? So who's heard of Spring Boot? A few people maybe made that talk. So Spring Boot does a lot of cool stuff, like it'll automatically, magically configure things for you just by checking out what's in the class path, like figuring out, should I create this kind of data source because this particular library is in the class path? Or maybe figuring out, I see a bean of this type has already been defined, so then I need to make some more infrastructure beans in the background. And that's what we mean by some kind of smart defaulting or programmatic approach to figuring out which beans need to be created. The way this is done is there's a new @conditional annotation, and this is backed by a condition interface. So condition's a strategy interface that you can implement on your own, and then do anything programmatically you want to with that. It's also given basically a condition context, so it's given access to the current basically bean definitions that are already present, so I think through the bean factory, things like that. Yeah, so you can check out like existing bean definitions, etc. And going back to profile, what we've actually done there is that we've taken profile and the code we used to have for that, we threw it away, and we implemented that now as a profile condition. So actually implementing this, and it says profile is now annotated with @conditional, and the condition is set to profile condition. So talking about eating your own dog food, this is a great example of that. And if you want to see how it works, you can check this out or check out Spring Boot. Now we looked at composable stereotypes before. So we talked about annotations and meta-annotations and how you could come up with your own my service annotation. And I mentioned, so that was a 3x timeline, right? And in 4.0, we've actually gone a step farther. I'm not actually sure who came up with the idea, but it's a really cool idea. So like I said, there's no support in the language, in the Java language, for inheritance. So if there's no support for inheritance, and there's no support for overriding methods and stuff like that. But we came up with a convention-based way. If you define in your custom annotation an attribute of the same name and the same type, then we assume that you're overriding a method, basically, in an annotation. So we call that attribute overrides. Might be special to Spring. Maybe some other projects do that as well. We're starting to do it rather often, in Spring Boot does it. Some of the other projects do it. Spring Integration, I think, and some of the, maybe, not yet, some of those. Definitely Spring Boot. So like I said, this is convention-based, matched by the name and the type. But one caveat here is that you're not allowed to override the value attribute, simply because value is a special keyword, in a sense, for attributes in Java. So here we have an example. We have defined our own @session-scoped annotation. We've annotated that with standard Java retention, saying this needs to be kept around at runtime. And we've annotated that with Spring's @scope annotation, hard-coding the scope to session. So this actually makes sense. It's a session-scoped annotation. Anytime we use that, the bean annotated with that would be a session-scoped bean. But we're going a step farther than what we had before. Now we're actually defining our own attributes within this custom annotation. So here we have scoped proxy mode default, and we're setting that to no. Now, I'm not going to show you the source code right now, but if you open up scope and look at the source code for this, you'll see it defines this exact same attribute. It's of type scoped proxy mode. It's named exactly proxy mode, and it has the same default here to, well, I think here you can set up, you can either copy the attribute from the original annotation, so from the target annotation, I'll call it, or you can come up with your own new default. So you basically have a way to keep the same default or define your own default for your purposes. One thing to note here is that we're defining the default. So I'm not sure if you're familiar with annotations, but anytime you define your own annotation, if you leave this off here, if you don't have a default here, then you're requiring anyone who uses that annotation to specify a value for that attribute. But if you give it a default, then the developer can leave that off. So that's important to keep in mind. And we see here, we're using this @session-scoped on our own scoped service test, and we're providing the proxy mode, so we're overriding the default, and we're saying we want to use to target the class for the proxy that's created. Instead of a dynamic proxy, it's going to use a cglib-based proxy for that. And if we had left this off, this proxy mode equals target class, then it would have picked up the no scoped proxy mode, meaning that no proxy would be created. So here we have this optional attribute override. Going beyond that, here we have another example, slightly different. Public at interface transactional service, annotated with @service from Spring and @transactional, setting up a rollback for exceptions, so for checked exceptions, not just runtime exceptions, which is the default. And here we're specifying read-only. So if you look at the definition of the source code of @transactional, you'll see that it has a public read-only attribute, and that is set to false by default. But here, we're not defining any default. So what we're saying here is that anytime anyone uses our transactional service annotation, they're going to have to decide true or false for that flag. So here, this is actually required. So we saw on the previous slide how you can have defaults defined and make them optional, and now we've seen how you can basically change the configuration for Spring. So by default, Spring has transactional set to read-only set to false, and we basically changed that behavior from Spring, saying that anytime anyone in our project uses this annotation, they have to make a conscious decision. Do I want to set read-only to true or false? Lazy bean resolution proxies. A couple of buzzwords there. So who's heard of lazy beans before? A few people. Lazy initialization. So it's a bit of background there. It's been around in Spring, I think, since 1.0 maybe, or somewhere around there, 1.02. Anyway, lazy initialization, everybody knows what that means in programming. And with Spring, there's this concept of saying that a bean will be lazily initialized. And that means you define the bean, you create the bean definition, for example, in XML or in Java config, but Spring won't instantiate that bean until it's first referenced by another bean, until someone manually, programmatically tries to retrieve that bean from the application context. So that's a lazy bean on the source side. And now we're talking about lazy bean resolution proxies. This is something new in 4.0. So now we're talking about on the injection point. In the past, it was on the source, so where you declared the bean. Now we're talking about where you want to inject the bean into. So if you're using @autowired or @inject and @lazy on your setter method or on your constructor, what's going to happen is this new support in Spring 4.0, if Spring sees @lazy there, it's going to say, aha, I need to create a proxy for that. So instead of creating that bean now, I'm going to dynamically create a proxy of the same type as that bean and inject the proxy. So that means if your code never actually interacts with that bean never gets created. But as soon as your code interacts with that bean, it's going through the proxy, and then it's going to be pulled out of the application context and instantiated. So basically, this is an alternative to two other options you've had until now. For many years, there's been the Spring Object Factory you might have heard of, and in terms of JSR 330, so common annotations for Java, like alongside with @inject, there's this provider API that you could have implemented. And this is also similar to something that you'll find in Google Juice for dependency injection and lazy initialization. But so now you have this support for @lazy in Spring as well. Has anyone ever injected a list of beans into a component? So it's somewhat of a lesser known feature in Spring. If you have, for example, @autowired list of, for example, repository, and you have multiple repositories in your application context, then Spring finds all the beans of that type, creates basically an array list for you, and injects that list. But the ordering, who knows? What order do you get them in? In the past, it wasn't really deterministic, and now in 4.0, you can actually control the ordering for the injection of lists and arrays. You can do this with two options. One, you can implement ordered from Spring, or you can annotate your beans with that order and define the order on those, and then they'll just be numerically ordered. So the order is then relative within this specific injection results. Dependency injection and generics, that's one topic that gets better with every release of Spring. Even for 4.1, we have some more things we're going to be working on there. But for 4.0, what we fixed there was the ability to have generic factory methods and supported in XML, and then have that work the way you would expect it to. So for example, if you're using something like Mockito or EasyMock in your integration test to dynamically create a mock of some kind of service or some repository, you can use that configuration, so your static factory method there. You could have also had your own custom type, and that now works as you'd expect in XML. And another thing that's much more important is type matching based on the full generic type, so not just part of it. But here we have my repository parameterized by type account, and that works. So it's probably best to take a look at an example of that. Here we have Java-based configuration, an @bean method. This bean method theoretically creates an account repository. That's the name of the bean, but the type is my repository. And if you ignore the account type information there, then it's just kind of a generic my repository. And in the past, Spring didn't really know what to do with that. But now Spring takes this parameterization into account, so that when you have something like this service and you're auto-wiring by type my repository account, Spring now actually does the matching as you'd expect. So this my repository, it takes this account into consideration, and it finds this actual account repository bean. So again, before 4.0, that would not have worked. In terms of proxies, who's used target class-based proxies, so CGLib? Is anyone aware of that going on in their code base? A few people. So there are a few limitations in the past in terms of arbitrary constructors and target class proxies. So previously, CGLib has been used for that, so code generation library, but with some side effects. So in the past, your constructor, your default constructor would have been invoked twice, once for your actual bean and once for the CGLib proxy for that bean. So if your constructor was doing something important like, I don't know, creating some files in the file system, then that code would get executed twice, and you probably didn't realize that magic was going on. So in 4.0, we use a different library. In addition to this Obgenesis library, it uses CGLib behind the scenes, but it has some smarts in it that allows it to instantiate your class without actually invoking the constructor. So that means we now support an arbitrary, or basically any constructors, and if you have constructors taking multiple parameters, then your target bean will get instantiated the way you would expect it to, and the proxy will not have that constructor invoked. Spring messaging. Who's heard of Spring messaging? Who's heard of Spring integration? Different project? Okay. So we talk about enterprise integration patterns in Java, and we talk about things like Spring integration or maybe Camel, so different projects. And in Spring 4.0, what we've done is we've taken some of the core concepts from Spring integration and moved them into the core framework. This resides in a new org Spring Framework messaging module, or Spring-messaging. And later versions of Spring integration will actually rely on this, correct? Right? 4, okay, so upcoming. Again, pulled out of Spring integration, changed slightly in some cases, but basically stays the same with core message and channel abstractions. So can we talk like pipes and filters, pipes being channels, things like that, and the messages, things we're sending along between clients and servers. Next up is the topic of WebSockets. Who's used WebSockets? Anyone? Two guys in the front? Okay, so very cutting edge. There is full-blown support for that in Spring 4.0. I'll just briefly touch on this if you're interested in more. There are several presentations by Ross and Soyanchev and some blogs as well. So there's a wealth of information out there. Basically in Spring 4.0, what we have is a new endpoint model that's analogous to the @controller model that you've seen before with Spring MVC, but for WebSocket endpoints. And of course, support for the standards. So JSR 356 is the standard for WebSockets in Java. But in addition to that, Spring provides support for SockJS and Stomp, so simple text-oriented messaging protocol, allowing you to use WebSockets with some fallback modes in case your browsers or servers aren't supporting, or your browser isn't supporting the WebSocket protocol. And you can implement these endpoints using generic messaging patterns. So that's why we pulled out basically these core messaging components from Spring integration, put them in core Spring, and then this WebSocket support actually relies on that core messaging support. Here we have a very, very simple example. My Stomp controller, simple Pojo class, annotated Pojo, so plain old Java object, not extending anything. annotated with @controller, just like in Spring MVC, it's the same annotation. But what we see here, instead of @request mapping or @request body like we would see with Spring MVC and Spring MVC REST, we see two different annotations here. This one, @message mapping, that's basically analogous to @request mapping from Spring MVC, but this is for messaging and given a path here as well, and then basically executing a trade for a particular domain object that's passed in and the current user. But what we see that's different here is the subscribe mapping. So that's analogous to the subscribe command that you would have in Stomp. And you're basically saying I want to subscribe to a particular channel and then get back information from that channel that someone else is publishing to that channel. And in the back end, you have some kind of messaging infrastructure that's running that you also configure with Spring. Yeah, so what happens is, I'm not an expert in this, but you basically have HTTP as the protocol. So typically you have a client, so you have a browser that's communicating with your server, and your server has to know that, that there's a WebSocket upgrade. So there's a handshake in the HTTP connection. The HTTP connection comes in from the browser just like normal, and then it says, well, I'm not going to talk to you with HTTP. I'm not a simple web page. I want to do WebSockets. So it does an upgrade of the underlying socket, and then it changes it to a WebSocket connection. And your server has to support that. So modern versions of Tomcat and Jetty are going to support that, and modern versions of like Wildfly, JBoss stuff support that as well. Does that answer your question? Yeah. Okay. Who's used the REST template in Spring? Yeah, a few people. So I mentioned before that Spring has support for RESTful web services using Spring MVC. And REST template is basically for running clients that invoke remote REST web services. In the past, if you used REST template, all the calls were blocking. That means you had to wait on the response. And now in 4.0, there's a new async REST template, again, analogous to the existing REST template. But the way you get this asynchronicity is you can implement this listenable future, and basically it's a way to plug in and get back asynchronous results. And this listenable future is based on some code or inspired by code from the Guava project in Google Code. Next up, supported SE versions and EE versions in Spring 4.0. A bit of history here. So 3.1 and 3.2, we're talking about Java 5 through Java 7, and Spring 4.0 is the first to explicitly support Java 8. Is anyone using Java 8? One person. Oh, two people. Okay. What IDEs are you guys using? Both of you? Okay, that's kind of expected. You're not going with Eclipse, NetBeans on that one. All right, Java EE support, 3.1 and 3.2. Spring, we're supporting J2EE 1.4, but deprecated, and then up through Java EE 6, and now latest version, so Spring 4.0 supports Java EE 5, but with this caveat here. You have to be using the JPA 2.0 feature pack if you want to use JPA with Spring there, and then providing support all the way up to Java EE 7. And with that, we have some updates for some of the enterprise APIs. So for example, we've upgraded to JMS 2.0, the long-awaited follow-up to 1.0, to whatever it was like 10 years ago. But new features like delivery delay, some of the new things like create session, JMS 2.0, Spring supports that as well. JTA 1.2, so an upgrade there. As I mentioned, there's a new @transaction orientation. It looks strikingly similar to the one from Spring, if you look at it. Strikingly similar. And if you leave off the JavaX transaction and you see @transactional, you're not sure which one it's coming from. Anyway, it could be Spring or the standard. JPA 2.1, Spring supports that as well, also with support for unsynchronized persistence context. And last but not least, a small upgrade for bean validation. So no longer just validating on your properties in your domain model, but also you're now able to validate method parameters and return values with new constraints for that. So now maybe some more exciting stuff. People are perhaps interested in Java 8 and using it with Spring. We'll talk first about the bytecode level. So when you're compiling, by default, right, you're going to have -target 1.8 with the Java 8 JDK. But doesn't work with ASM 4.x. which is Spring's bytecode parsing library. So Spring uses cglib and ASM. It uses ASM to look at bytecodes, to look at classes without having to actually load the classes in the class loader for some of the internal things that it does. And to overcome that, in 4.0, in the first release, we had to basically use a patched inline version of an upcoming ASM 4.1 variant, and we jar-jarred that. So who knows what jar-jar is? And this is when I say, I'm not talking about Star Wars. Does anyone know Jar Jar outside of Star Wars? Yeah? Yeah? Okay. So Jar Jar is a project on Google Code that allows you to take a jar, change its internals, and say, I want all the code that was in there in a different set of packages, and put a new jar. So what we do there is we take ASM and we take cglib, and we put them in our own org.springsframework.asm packages. So basically that allows us to rely on a particular version of ASM that we need. For example, this patched one that we wouldn't want to force on you. And it allows you to pick another version of ASM in your code, or your third-party libraries can pick a different version of ASM. Like I said, we do the same thing for cglib and for Obgenesis as well. But with Spring Framework 4.0, there's now an official release of ASM 5.0 that supports Java 8. But again, we inline that and jar-jar that as well, so you can pick a different version of ASM if you need to. But just things to keep in mind. Some of these things that impact your code, like AspectJ or cglib or ASM, if they're relying on bytecode analysis, might not work immediately. Moving on to some finer details, so hash map and hash set, there are some differences in the implementation in the JVM. So they have different hash algorithms that are in use. Hopefully it doesn't affect you, but depending on how you write code, it might. So you get different hash iteration order, and you really shouldn't rely on that. You shouldn't have relied on it. But when you upgrade, you might want to make sure you're writing enough tests to see that your code works the way that you hope it would on Java 8. Moving on to Lambda conditions. So we're talking about things like closures in Java. What is a Lambda? Well, we have one simple rule. Basically, it is an interface with a single method. Pretty straightforward. And what is that typically? Typically, that's going to be something like a callback interface. For example, straight from the JVM, you might want to use something like runnable or callable. They both define a single method. And because of that, they used to be called single abstract method types, which I was very fond of because it's my name in all caps. But they decided, not so cool. Anyway, if you're searching on the internet, sometimes you see SAM types or single abstract method types. But nowadays, you'll see more talk about functional interfaces. And in fact, in the final version, Java 8, there's a new @functional interface annotation that basically says an interface is actually a functional interface and would be an error if it were if you add an additional method. This isn't required, but you can look at the Java doc for that if you're interested in that. So what does that mean to us? Java 8 and Lambdas plus Spring ends up being quite a nice natural fit. Beauty of simplicity. We're lucky because many Spring APIs are automatically candidates for use in Lambda as Lambda functions. And that happens just out of coincidence, simply by following the Lambda interface conventions without having known it. So a lot of the callbacks that we see in Spring, they have just one method that you have to implement. For example, with JMS template, there is a message creator callback that you can implement. It defines one method, create message, takes the JMS session, and returns a JMS message, like a text message, etc. Another example with Spring's transaction template, it has a callback named transaction callback that allows you to do something within a transaction. And simple method you implement, that's a great candidate for a Lambda expression. Now, JDBC template, we'll look at this in more detail so you get a better feel for what we're talking about. Who's used the row mapper before in Spring's JDBC support? A few more people? Okay. So this is one thing that I tell a lot of people. If I didn't use any other part of Spring and I just wanted to write JDBC code, so SQL interaction with the database, I would use Spring's JDBC support, JDBC template, and the row mapper. It's a great tool for interacting directly with SQL if you don't want to go to full-blown OR mapper like Hibernate or JPA, etc. So basically, what it has is this really simple callback here. You want to map a row. So from the result set, from the current row in the result set, we're talking about the JDBC result set here. This row num represents the number you're currently on. Spring manages all this work in the background, you just implement this method. You take the result set, get the information out of it, and you create your object. So for example, you might be creating a user object or an account object, something like that, from the current row that was returned in the SQL results. And this is a great candidate for use as a Lambda function. Here we see real-life example. So we have a JDBC template from Spring's JDBC support created somehow with access to the data source, also with transaction management somewhere in the Spring config. And then with this JDBC template, we have this query method. We don't have the source code here, but basically it takes a string. The string can have placeholders in it, so SQL placeholders with this question mark here. And then it takes what's called a prepared statement setter. That's something from Spring. And what that does is it takes a prepared statement and it sets the values in it. That's its job. And then the next parameter, so we say parameter, comma, parameter, comma, parameter. This next thing here is the actual row mapper. So the row mapper, again, this is interface. In the past, you could have implemented it as a standalone class. Maybe it's a static inner class. Maybe it is an anonymous inner class inlined right there in the code. But again, what you had to take here is a result set, first parameter, int is a second parameter, and then return an object that you instantiate. That's the goal. So here we see that. We have two parameters, rs and row num. That's this result set and this row num. We don't have to specify the type if it's straightforward there. And then this arrow here is Java 8 Lambda. We're saying basically this is the argument list, and this is our function. So we're pointing over here to the function. And what this does is this just says, create a new person from results at get string 1, results at get int 2. And if we look here, we had the select name and the age. So the name is the string, first position, and the age is the integer in the second position. So it's a very streamlined way to implement this row mapper interface just as a Lambda function. Has anyone written Lambda functions already in Java 8? A few people. In other languages, maybe? A few people as well? Okay. So if you have any questions, just ask. I'll show another example here. This is the simplest way you could do it if you want to have it a bit more spread out, formatted a bit differently. You can actually add in the brackets there, so you can have your arrow Lambda function pointing to a code block there, so basically the body of your function, and then you can have multiple lines executed within there. And here we see that as well, but now we have the explicit return. So we could have had several lines here to do something programmatically, whatever we need to do, and then the end return. And again, on this one, if we write it in one line like this new person, that ends up being the return value, so we don't have to actually use the keyword return. That's it for lambdas. The next one we have is method references, which a lot of people might not be familiar with, but that's something also new in Java 8. Does anyone see anything on here that would not compile on Java 5, 6, or 7? Anyone? Yeah? Right. So this thing here, what is that, right? That wouldn't compile on anything before Java 8. That's a method reference. And here we're referencing it from the current object with this. You could also reference it, a static method, for example, in another class if you wanted to. So we're on this particular object here, we have mapPerson. That's the name, and that references then this mapPerson method. So keep in mind what we had before. Go back a bit. Row mapper has a method. We don't care what the name is. We care about the argument types. It takes two arguments. The first is a result set. The second is an int. It returns an object. That's what we care about. We don't care that it's called mapRow. So if we go here, this method's called mapPerson. That's fine. But Java looks at it and says, OK, what does the argument list look like? It takes two parameters. First, result set. Second is an int. And it returns an object. So it's a candidate. It can be used there as a row mapper. So it's a nice way to reuse code within the same class, or you could have another method implementing basically the interface or the contract for row mapper, but defined as a static method somewhere else as well. So that's another nice feature we have in Java 8. And again, this code here is using Spring, but it's actually Java 8 that's supporting the method references and the Lambda functions. It's just nice that Spring's callbacks work automatically with Java 8. So some of you said you used JOTA-time as a replacement for standard date and time support in Java. And with Java 8, we have GSR 310, so date and time specification. You can use that. So you can use from java.time.start, we have local date and local date time. And we see here this is a domain object, customer. These are the fields. So we have a birth date and a last contact date time. And what we have here is this date time format. That's an annotation from Spring that allows you to define how this field should be processed when it's created, converted into a string for display, for example, in your web application and JSP page, or coming the other way around when a string comes in as an HTTP request parameter, how it will be converted back into a date object. But we see here now with local date, this nice benefit. Local date says this is a date. It doesn't have the problem that we had in the past with Java where it could have been a date with a time, with some seconds, right? So with local date, we know that it's just a date. So we can actually leave off this annotation. If we had date in the past, we would have needed this with Spring, but now we don't. However, if you want to use a specific format, you can then specify it. So for example here, date time format specifying a pattern there. You can be explicit if you want. The default, however, would just be to use the ISO standard for date formatting with local date or a local time. Repeatable annotations. @repeatable is a new annotation in Java 8. What it says is that you can have an annotation declared multiple times on an element. In the past, that was impossible. So who can say which code works on Java 7? Does the top work on Java 7? No. Does the bottom work on Java 7? Yes, right. So here we see we have this @schedules and then some scheduled annotations inside there. That was always possible. You could have done that since Java 5. But what's new is in Java 8, you can have the same annotation multiple times, for example, on a method or on a class. But you can only have it there if this annotation is itself meta-annotated. Remember that term? Meta-annotated with @repeatable from Java, and if the @repeatable annotation declares another annotation that's the container. So then with Java 8, you have the option of either using repeatable annotations without the container or explicitly using the container. The nice thing about the container is that it works with Java 7, Java 6, and Java 5. So @scheduled is from Spring's scheduling support, and @schedules is a new annotation in Spring 4 that works with Java 8, but also works with Java 7 and Java 6. So you could use this on previous versions of Java with Spring 4, or you can go the new route if you're actually running against Java 8. So here again, this is a repeated annotation. Works only on JDK 8. And the other, we have this container, explicit container, and that works on Java 5 and above. So @schedules is not the only annotation. I think there's about 3 or 4 in the 4.0 and 4.1 timeline that actually make use of this this @repeatable annotation feature. Parameter name discovery. Again, I mentioned this. Most people have never heard of this in Java 8, but it's actually useful in Spring. So what's new? In Java 8, there's a new parameter reflection type that allows you to, figure out what the names are, for example, of parameters passed into a method using reflection. But that's only available if you compile your code with dash parameters. So you might be familiar with the dash debug compile time flag from the past. So what we have here now is a standard reflection parameter name discover. Mouthful there. What it does is basically it tries to read parameter names using Java 8's new parameter type if it's available, and then we have this default parameter name discover which delegates to that, and it first checks to see if it can find the parameter names using Java 8's parameter support, meaning if your code was compiled with dash parameters of Java 8, and if not, then it will use ASM-based reading of debug symbols, so pulling up the name of the parameter from the actual bytecode if you compiled your code with dash debug, and otherwise it's going to fail and not be able to figure out the parameter name. So if that all seems a bit Greek or bizarre, let's look at a concrete example. Here we have a Spring MVC controller class. We have a method here, @request mapping method find book with this @path variable. If you're not familiar with that, what that does is it basically pulls out a variable from the path defined by a placeholder, and the placeholder is surrounded here by curly brackets. So this ID is a placeholder, this path variable, and we want to have it mapped onto a parameter to this method. This one's pretty straightforward. We only have one method, but you could have multiple, one parameter. Here you could have multiple parameters, and you want to have them matched by name somehow. Now, you might have seen a lot of examples of that path variable with parentheses and then the name. You can actually be explicit about what the name is. But what I'm showing you here is if you leave off the explicit name and you say, please figure out what the name is of this path variable, then if you had compiled your code with dash parameters, then it would use the new parameter API from Java 8 to figure out. And otherwise, if you compiled your code with dash debug, it would use ASM and bytecode inspection to figure out that this name of this parameter is ID. Because otherwise, in terms of the bytecode, it could just be like argument 0. And I seriously doubt you named your variable there argument 0, right, in your path variable there. So anyway, that's one nice feature that you can use with the dash parameters instead of having the dash debug for the debug symbols in your bytecode. Yes, exactly. So that's it for 3x and 4.0. Now we'll talk about some of the new features, some that we've already implemented, and some that we're thinking about or already committed to implementing in the 4.1 timeline. Some of the themes. First up, comprehensive web resource handling, so for static resources. Then added support for caching, so we're basically revisiting our caching support, adding in support, explicit support for JCache 1.0 annotations. We'll see some examples of that, but also some user-requested enhancements, for example, things like adding a new put if absent method in the cache. Yes? Yep. I think just the size, yeah. Yep. JMS, so JMS 2.0 came out, started supporting that in 4.0 and in 4.1. We are now aligning the JMS support that we've had for years with the new messaging module that we have, so the Spring messaging, so you see some similarities between WebSocket support, Stomp support, and JMS support in terms of annotation-driven endpoints and how you can route messages there. So it's a much more natural fit. Yeah, time for a good upgrade there. Also, as you'd expect, some performance and container improvements in general. So application startup times should get better, spell expression evaluation getting faster. Again, dependency injection for generics and factory methods, always improving. People always finding issues there, making that better all the time. One thing that I'm spearheading is a new unified meta annotation programming model. So we've had support for custom stereotypes, and then we just added support for annotation attribute overrides, like I showed you, some custom overrides there. But it's not a very unified model in terms of sometimes we use reflection to look stuff up, sometimes we use ASM to look things up. And then I mentioned before that in up through 4.0, we have this support for the attribute overrides, but you couldn't override an attribute named value. So we've come up with a way to do that. We're basically going to define an annotation that allows you to specify explicitly what attribute you're overriding and from what annotation. And that will solve a few things. So right now, the examples I showed you earlier were quite simple. We just saw basically overriding the read-only flag from @transactional. But what if you had two annotations you're using as meta annotations, and they both have an attribute called name? That happens rather often. It happens a lot in Spring. There's lots of things that just called name. So the way it is now with Spring, if you had that, you would be using name for both of the annotations, and you wouldn't know which one you're overriding. So in 4.1, we're going to make that explicit. Excuse me. And yeah, assigned to me, lots of new testing features. As I mentioned before, we have support for Groovy in 4.0, Groovy config files, but no way to test with that, so we'll be adding that in 4.1. Also, new support for SQL script execution. We've had that in the past, but now we've unified that, adding in some more annotation-driven support for tests as well. There's a new bootstrap strategy. I think I'll talk about that in a minute for testing, aimed more at hardcore developers, architects, and third-party framework implementers, but something that's new there as well. And another feature that's been asked for years is programmatic starting and stopping of transactions within tests. So I mentioned this before as well. Web application context, we'll be adding in a Groovy web application context in 4.1. If you see these numbers here, it's meaningful if you're interested. This is from the JIRA issues, SPR for Spring Core Framework, and the JIRA number. I've listed that alongside a lot of the features here that you can check up on and follow the progress for if you'd like to. And I'll make these slides available on SlideShare so you can have access to this later on. Static resource handling, we'll take a look at that in detail in a second. Also, we'll be adding a new WebSocket scope. So in the past, we've had things like request scope and session scope for web applications, things like step scope in Spring Batch. And now with a WebSocket in 4.0, we're adding a WebSocket scope in 4.1. This static resource handling. So what are we talking about there? We're not talking about dynamic resources like a JSP page that gets invoked on the fly and defines some HTML for you. We're talking about things like JavaScript and CSS and images and stuff like that. A lot of times, you don't want to just have that in your war. You might want to pull that out of a jar file, maybe have it versioned somehow. Maybe some other team provides the JavaScript. Maybe you have some needs to have those stuff compressed, gzipped. Maybe you have needs for like minifying the JavaScript, etc. You have some frameworks for that. And now we have explicit support in Spring for that. That's actually already in the 4.1, so in the master branch if you want to check that out. There's a new resource resolver API for doing exactly this. So basically you can resolve internal static resources, for example, from the class path. And you can also resolve the external resource path so you can tell the external user how you reference this via an HTTP link to get a hold of this resource. And then internally, if you've ever used filters, so a servlet filter and the filter chain, this is analogous to that. So there's a resource resolver chain that manages several resolvers and allowing for delegation from one resolver to the next. The way you configure this is via the resource handler registry, for example, with WebMVC configuration support if you're using Java config. So here a concrete example coming up in a second. The implementations out of the box, there's 4 right now. There's a path resource resolver, which is the default, configured by default if you don't set anything, and it should always be configured at the end of the chain. You can also use a prefix-based resource resolver. So for example, defining a custom prefix, maybe it's the current version of your JavaScript files, or release date, something like that. Or something a bit more unique, maybe the fingerprint resource resolver that uses an MD5 hash for the uniqueness of the contents of the file, adding that into the file name, and then allowing you ways to parse that out and tell the client which version or what the name of the file is to use. And I mentioned before, you might need to compress large JavaScript files. You can do that with gzip compression and use the gzip resource resolver to make sure that's handed back to the client appropriately. So here's an example from Java configuration for Spring MVC. So we have an @configuration class that extends the web MVC configuration support. This class has this add resource handlers method that basically gives you access to this resource handler registry I was talking about on the previous slide. And with that registry, basically what you can do is you can add a resource handler. For example, here /resources ***. So anything coming in under that path, basically you have like CSS and JavaScript underneath that. And then you're pointing to some resource locations from the class path, so within some jars in your web application. And then setting the resource resolvers. So this is this new API. This is the new part. And this is a chain. It's just basically an array of these resolvers. You could have some custom ones you write on your own, or you can use some of the 4 that come out of the box. And as I mentioned before, the path resource resolver should be the last in the chain. So again, create the chain. Order matters here with this list. And then just register the chain with your resource handler.
Is this replacing the MVC resources?
This is actually the same thing. That add resource handler is the MVC resources. This is new. This resource resolvers is the new part. So basically, in the past, with the resource handler, you had this HTTP resource handler. It had the functionality for this path resource resolver baked into it, and that's now an external component. That's why it should go last in the list. And you now have this chain that allows you to do different things. So you can basically have this path resource resolver at the end, but you could maybe zip the files in the process or change the file names in the process, and you have basically like a chain. It's like analogous to the filter chain in a servlet container.
So if I have a JavaScript file I'm referencing from my index.html, and I need that so it's so that the browser cache doesn't override, and I need a version on it. Does this go into that index.html and update it to like the MD5 hash?
That's still being developed. So this is a work in progress, and this was just committed like 2 days ago. They're working on that, and they'll be coming out with some examples for how to integrate that into your JSPs and stuff like that. But as I mentioned, let me go back. Yeah, I mentioned before, there's 2 sides to it. There's the one when you implement one of these resolvers, it has two methods in it in this interface. And the one is get me the resource from wherever, probably from a jar file or from the class path or something. And the other is give me the external name. So like internally it's called, I don't know, main.js or something like that. But externally it has the hash prepended to it or in the file name. So that's why you have these two methods there. And yeah, as for how that's going to be linked into the JSP, there might be like a tag or something that allows you to specify that. But they're still working on that.
So would that eventually kind of like cover some of the functionality provided? Like right now you have to use third-party libraries like Bro4j or JIWR, kind of like that provides a kind of resource handling, and would that potentially even go into like the areas of like I guess minification or even like merging?
Yeah, you could implement your own to add in those parts. Yeah, that's what I'm saying. So out of the box, there's just these four, but someone could implement them or third parties could implement them, and then you could configure it in the chain. And you could add the minification. That's what I was saying. So by default, you just have this path resource one, which basically just says it can get it from a path and it knows the name, it can return it back. But you could add in compression in there in the middle. You could add in the MD5 hash into the name for caching based on the contents. And you could, before that, before you generate the MD5 hash, you can minify it, stuff like that, right? Yeah. But as far as I know, like the minification, stuff like that, that's not something that Spring wants to do, but you could plug it in. So caching, JSR 107 standard, one of the oldest JSRs around, right? Finally got implemented. Basically in Spring 4.0, we now have explicit support for JCache 1.0 annotations. You might have seen the blog last week. Just came out. Was it last week? Basically, this is implemented, the integration is implemented on Spring's existing cache and cache manager SPI, and explicitly there's a new JCache cache and the JCache cache manager, as well as some other infrastructure support there. And these can be enabled via the standard caching configuration mechanisms in Spring. With XML, you can now use a cache annotation driven and enable caching. So the new part here is the annotation driven part that's adding in support for JCache there. Yeah. And again, yes, this blog, 4.14, you can read that if you want some more details there. And he'll be coming out with another blog in the near future as well on some of the other changes to Spring's caching support. So there's not only support for JCache 101, there's also some changes to Spring's caching support as well coming in 4.1. Here's just a quick overview in terms of the annotation supported. So Spring has had these annotations for a while: cacheable, cache put, cache evict all entries, and here you can see what that maps to in JCache. So the cache result is the same as cacheable, cache put, same name, does the same thing. Remove instead of evict, and here they have remove all, so they have a dedicated annotation in the standard that achieves the same as this. There's some additional support in JCache, for example, caching of exceptions that are thrown in exception handling. That's not part of core Spring, but there'll be some work being done on that and some more information and blogs coming on that as well. JMS, as I mentioned, we're aligning that with the Spring messaging module, so it's more one-to-one mapping there. One of the biggest changes here is this new addition of annotation-driven endpoints. So originally, you would have had to implement a message listener a long time ago, and then in Spring 2.5, I believe it was, we introduced this JMS listener container for XML-based configuration. So you could basically have your POJO service, and you could say, when a message comes in on JMS on this queue or this topic, I want this method to be invoked to my service, and automatically marshal and unmarshal from the JMS message type into my model types with a configured message converter. But again, that was using XML as a configuration, and now we have this new @JMS listener. Also just came out, got implemented, checked in the last week into master for 4.1. So basically, you can annotate methods with JMS listener, and that's the same as having had a JMS listener element within the JMS listener container in your XML configuration. And this can be configured with JMS annotation driven. That basically says, find all beans in the application context that have methods annotated with JMS listener and use them as message listener endpoints. And for Java config, we have @enable.jms and a special JMS listener configure interface that you can implement to configure that in more detail. So here's just one quick example, the simplest example perhaps with Java config. So we have an @configuration class annotated with @enable.jms. And what we have here is a JMS listener factory listener container factory that we are creating. We're using the default one here, setting up the connection factory that's coming from somewhere else. Here I just say add other bean definitions, configure elsewhere. So some connection factory, destination resolver for your queues and topics, setting some concurrency settings, etc., and returning that. And then basically just having this enabled JMS and having a bean of this type gets you up and running. And also this also tells Spring to find components annotated or with methods annotated with JMS Listener. So for example, in that application context, if we have a service, some component that has a method annotated with @JMS Listener, specifying the container factory. So again, that's this one here by name. We're also working on having ways having that auto detected. So this might not actually be necessary next week, as early as next week. But you do need to specify the destination, right? So either the name of the queue or the topic. And then you can process that incoming message as you would. So a text message comes in on this queue and gets converted into a string, and you can just work with it there in your service method. Sorry, I've been talking quite a while. Some container odds and ends, closing up here. There is a new JavaX annotation, priority annotation. I don't know if anyone's ever heard of that. But we came up with the idea that it would be nice to have that, or be able to use that standard annotation as an alternative to some of Spring's annotations. So Spring already has this @order and @primary, and you can now use @priority, specifying a number, priority number there. It does the same thing as order, and then it's a replacement for primary, but an extension of primary. So has anyone ever heard of primary beans in Spring? One person. With Spring, we talk about dependency injection by name or by type, and mostly by type. So if we use @AutoWrite or @inject, we're injecting some component based on its type. And if we have multiple beans in the application context of the same type, then what's Spring supposed to do when you say I want one of them, right? So Spring has to somehow know which one of that type. One thing that it does is that it uses the name of the bean as a qualifier. Another option is that you can use an annotation called @qualifier, which allows you explicitly set the qualifier. And then another option is to say, I might have 2 of them or 10 of them, but I have one primary bean. It's like the main bean of that type. And then if you have that situation, then your component would receive the primary one instead of one of the other ones. But that's limited because you can only have one primary. So what I'm saying here is just with priority, @priority, you could set varying priorities on all of those beans. Maybe you have 10 beans and they have priorities 1 to 10, and then the highest priority one would be the one injected when you only ask for one of those of that type. We're here. Still talking. But I've been told I have longer than an hour, so I think we're good. All right, moving beyond that, annotation-driven application event listeners. Some of you might be familiar with the fact that Spring's application context supports its own eventing mechanism. You can do that by implementing application listener, and don't think I have that listed there. That's parameterized by a type of application event. But one of the downsides of that is that you have to implement a new class, so you have to implement that application listener each time that you, or for each type of event that you want to listen to. But now, this name might change. This is a proposal here with this @listen. What you could have is in one class, you could have multiple @listen methods, each receiving event objects, application events of different types, and then Spring would automatically invoke the correct one each time one of those events was fired in the application context. So it's just another way to reduce code and use annotations to achieve that goal. Yeah, they can be, yeah, like start up and shut down, or even your own custom ones. You can also send your own application events in the application context. Yeah, and again, if you want to track some of these, you have the Spring Jira issue numbers here for more information. I mentioned this before, so this unified meta annotation programming model with custom attribute overrides, value aliases, etc. This is the umbrella issue for that, and we have a couple of sub-issues there. You can follow on that, along with that if you'd like to. Testing with Spring 4.1, as I mentioned, we're going to add support for Groovy config files for your bean definition, so then you can not only write your application code in Spring and your configuration, in Groovy, of course, everything's in Spring, in Groovy and your configuration in Groovy, and now your tests in Groovy, and have it all 100% Groovy. and that'll be groovy. So here we go, SQL script execution and database configuration. Like I said, we've had this for a while. We just implemented script utils, I think, in 4.03. So we consolidated some of the code we had there before in core JDBC and in the testing framework. And now we've enhanced resource database populator with some more options there. So if you've been using that, you might want to check it out and see some of the new settings you have there. This is also a tentative name for a new feature in testing, so something similar to a smaller version of maybe something like DB unit, but where you specify the name of a script saying for each test method in your test class, I want to have a different script executed within my test transaction. Here, this test context bootstrapper strategy. You might not use it as an individual developer, but you might use it on a larger project, or you might find that some third-party frameworks are using it. Basically, what you can do with it is you can decide which default text execution listeners are used and what the type of the context loader is. So we use this internally for the web testing support, so to figure out that we need to have the servlet-based text execution listener, or that we need to have the to load a web application context, and some other frameworks like maybe Spring Security and Spring Batch might be able to benefit from this as well. And yeah, last but not least, this new support for programmatically starting and stopping transactions within your transactional test method. So in the past, it was just that a transaction would be started before your test and then roll back at the end. But people have said they want to be able to stop one, check something, and then start another one, and make sure that the code is working as they would expect in such use case scenarios. Yeah, and some more caching and performance improvements as well. So here, just to kind of show you some of the added functionality we have here, not specific to testing. You can actually use this for just setting up any kind of embedded database. With the embedded database builder, you have some new settings, ignore failed drops, adding scripts, setting the comment prefix, setting block comment delimiters for the start delimiter and end delimiter, other things like that. Just a really simple way to get an in-memory database configured and launched, and then shut it down at the end. So, roadmap. We hope to release RC1 in June of this year. So not having any milestone releases, just going straight to an RC1. Then with RC2 followed up in July, so probably towards the end of July, with approaching Spring 1 2GX, you might imagine, 4.1 GA coming out sometime in September. So we do encourage people to go ahead and start checking it out. Maybe some of the snapshots if you're interested. Maybe follow along on some of those Jira issues, and definitely when RC1 comes out, please give it a try and let us know what you think. In closing, a few notes about upgrade considerations if you're on the 3X timeline now or looking at 4.0 and 4.1. First up, Spring 3.2 does not support the 1.8 bytecode level, so it's just not going to work. The reason is for things like bytecode inspection with things like ASM and CGLib. So if you want to have full Java 8 support, you need to upgrade to Spring 4.0 or higher. But there's a caveat. I just added this on the note today, on the slides today. The upcoming last release of the 3.2 line will be 3.2.9, and Jürgen just added some partial support there with for Java 8 bytecode, some upgrades there for CGLib and ASM. So some things might work with Java 8, is what I can say there. But it's not full-blown support like you have in 4.0. So with that in mind, we strongly recommend you upgrade as early as possible to 4.0. But keep in mind, even if you do upgrade to 4.0, you can still run against and compile against Java 6 and Java 7, so that's not a problem at all. Just don't use any of the Java 8 features, so you couldn't use the repeatable annotations or the named parameters or the, some of those other things, or lambdas, for example. And 3.2 is in maintenance mode, so 3.2.9 will be the last release, and I believe 4.04 will come out next week, the week after, and then 4.05 will probably be the last release in the 4.0 timeline as well. 4.0 came out last December. 4.3, exactly, just said that. That's it. And mentioned before, 4.1 scheduled for 2.0 for September 2014. So coming almost around the corner, as it would seem. Acknowledgements, they're not here, but thanks to Jürgen and Stefan, they let me use some of their content. And some resources. Again, I'll make the slides available so you have the links here. Hopefully you know them, but Spring.io, the main webpage, Spring Framework can be found there. The forums on Spring.io as well. Jira, if you find any bugs or have any recommendations for things we can improve or documentation errors, typos, stuff like that, please let us know. Just create an issue. And if you'd like to follow along with the code or check it out or even commit yourself, it's quite nice on GitHub these days with pull requests, very streamlined, makes it easier for you and for us, much better than working with zip files like we used to do in the past. Much better. So in terms of blogs, I have a blog on my company page there, and there's the official Spring blog as well, so spring.io/blog. So you'll find some of that information on Spring 4 and Java 8, as well as some of the new, more recent blogs on the caching support, and there should be a blog coming out as well on the new JMS support in 4.1 as well. So if you need to contact me, you can follow me on Twitter, ping me there. You can send me an email, and as I said, I'll put these slides up on slideshare.net/sbrannen. So that's it. If there are any questions, I'm happy to answer. Yeah? Well, you shouldn't be using any of the JUnit 3.8 support or any of the old stuff like the simple JDBC template. Those things just got deleted. Yeah. Some of the old MVC stuff, some old, which one was it? Burlap. Some old stuff got deleted. Just some of the stuff that if it's deprecated in 3.2 and you see that, what I said earlier, and I really mean it, in your IDE, don't ignore the deprecation warnings if you're on Spring 3.2, because when you upgrade to 4.0, it might just not compile. Yeah, and it's better to look in advance while the code is still there that says deprecated in favor of using something instead of it's just missing and not there, right? Then it's a mystery, right? But we do actually publish with releases. There's a special web page that shows you a diff, so a JDiff, Java diff, that shows the differences in the API changes from one release to the next. Yeah. Yeah.
Where is Spring Security in the pipeline?
Where is it? Rob Winch is working on it. He's doing quite a bit of work. Do you guys have a better answer to that one?
I know Spring Security OAuth 2.0 RC1 just was released.
Yep.
I know Spring Security is also moving along, but I don't know where it is in the release process.
I mean, there's a lot of Java config in the Spring Security stuff, and he's doing a fair amount in the testing. He is the biggest finder of improvements and bugs in the mocks for the Servlet API in Spring. So I know that he's doing that for Spring Security, and he also has additional testing work, the HTML unit testing stuff and some JEB testing stuff as well that builds on the test context framework and the also the Spring MVC test framework. So, but that's somehow all kind of related to web and security as well. Yeah.
We use mock MVC for Spring MVC testing. Is there any plan to support mocking private methods? Because we are using PowerMock and we use PowerMock rule along with Spring JUnit runner, and it's having some issues. It's not very stable.
You say the last part again?
We are having some issues with that because we won't be. It has some class loader configuration or something, and we are not able to run from IDE and run only from command line. So we are expecting
with the Mockito runner. Is that what you said?
Or the PowerMock.
PowerMock runner.
PowerMock with EasyMock. That's what we use.
Okay. So the Spring MVC test framework and Spring's testing support in general. When we say mock, we some of the things aren't actually mocks in the sense of what you're talking about, like a dynamic mock. We don't do anything with the class loading. We don't do anything like EasyMock does or Mockito does. We're basically more of a dummy in that sense, instead of testing dummy instead of a testing mock. So let's mock a stub.
That you have, that's good. But we would expect some support for like PowerMock test.
But that's what I'm saying is that Spring doesn't aim to fill that gap because that's taken very well by PowerMock and Mockito and EasyMock, right? Those frameworks specialize in that. So like the Spring MVC testing support is just about mocking basically the dispatcher servlet and not forcing you to deploy your application into a servlet container. So it's mocking out that part in that sense. And in terms of the servlet mocks and the portlet mocks, it's a misnomer. So they're not actually mocks, they're actually what's called a stub in terms of testing terminology. It's just unfortunate that someone named them mocks about 10 years ago, so they still called mocks, but they're not mocks. There's a good article by Martin Fowler. It's called "Mocks Aren't Stubs," right? Or "Stubs Aren't Mocks." Mocks aren't stubs. Yeah.
So there are some upgrades in mocking easy area because I had to do some shortcuts for mocking easy to implement mocking easy. Is there any upgrade in the latest Spring 4?
Is there an upgrade? If you have issues, we would be happy to know about them. There's definitely improvements that are taking place there. So we're improving some things and adding some new features. But I mean, if you're having explicit issues where things aren't working, then well, I think we don't know about them. So you should let us know. Yeah? Anyone else?
Related to, is there any interoperability between CDI and Spring? I mean, I see them as competitors.
Yeah, there's no interoperability in terms from the Spring side. It's not that we provide any kind of CDI support, but Spring you can use with Java EE in general. So, but yeah, there's definitely some overlap there. So you'd have to basically make a decision there which parts you want to use. I mean, if you're using the.
Is there any way to like inject a CDI bean into like a Spring component?
Can either one of you answer that? I think you have to have a special interceptor or something. There's nothing from the Spring side for that. I think there might be some third-party things out there, like people playing around, but I'm not sure if there's something official.
I never had to use CDI, so I kind of avoided that whole subject.
Okay. We can maybe talk about it later, but I think that's probably the most we can say. There's no explicit support for that. Anyone else?
The async REST template, is that only part of the core Spring, or there's a REST template in Spring Android, and to do async we have to use it in async task if you want to use it in Spring in the Android. So is that going to be in the Spring Android too?
I don't know anything about the. Do you want to answer that one?
I probably can't. I'm actually the project lead on Spring Android.
I was going to say he might be better.
Yes. So as you've been aware, the company's been going through a lot of transition, and the project hasn't received a lot of attention the last few months. But we are going to be migrating a lot of the modern current changes in the REST template over into the Spring Android and adjusting them where it's applicable for the Android environment versus servlet container. So do look out for some releases coming up soon, hopefully. Yeah, we do have plans to do async REST template. We're talking about what we can do with WebSocket on Android. So we've got some conversations.
Anyone else? Going once? Going twice? Okay, that's it. Thanks.